So I'm going to be the next speaker, and I'm going to be talking about the Acusensor and the real-time quantification of acupuncture needling. Now, why would we want to study needling? Well, I think we all realize a statement of the obvious that all needling is not the same. I'm showing a couple videos here of how different a couple of techniques look. And we could show 100 different videos and get 100 different looks. And I think that's pretty obvious to most of us. And if we just look at all the different words, and these aren't all the words, we could fill the whole screen with words describing needling, couldn't we? Things like reducing and slow, fast in, slow out, even, shallow. There's one in CAM that's called penetrating heaven coolness. There's rapid, reinforcing, TCM style, Japanese style. And we could go on, and I think most of you are familiar with these techniques, so it's no surprise. Well, what kind of challenges does this pose for us, all these differences of techniques? Well, from a clinician perspective, how do we communicate about needling? One clinician might say to the other, I tonified spleen 6. Now, does the other person really know what happened? They know the point, and they hear tonify, but there's hundreds of different ways that tonification happens. From the researcher's perspective, how do we control these needling manipulation variables? Is it important? A researcher might be communicating with a reviewer, for example, in the methods section, and they might say, spleen 6 was needled using a reinforcing technique. Well, does the reviewer really know what happened? From a teacher perspective, it's very difficult to learn, most of you know, it's very difficult to learn needling techniques. A teacher might say to the student, watch while I demonstrate the reinforcing technique. Do you see that? It felt like a fish. And the student is their eyes are getting big and they're wondering, how am I going to do that? Once again, from a researcher's perspective, how do we deal with this whole problem that we've talked a lot about the minimal differences between real and sham acupuncture? And some person might say, well, true needling isn't much better than fake needling with a toothpick. And a frustrated researcher would have to admit, well, we don't really understand needling that well. Maybe sham needling is active. Maybe true needling is suboptimal. How do we know if we're not really measuring what's going on, or if we don't really understand it? Well, how do we sort this out? Well, we turn to our super engineers. They save the day, right? But we can see that if we translate all those clinical descriptions like penetrating heaven coolness, and we apply engineering terminology, we start to be able to measure and quantify and actually communicate precisely about what's going on. So we talk about things like frequency, amplitude, speed, and force. And with needling, these can be broken into two components. The axial needling measurements, that's what happens in and out and lifting and thrusting. And we'll see in the next slide the rotational needling measurements when we rotate back and forth or one direction or the other. So you get the sense that we can apply these things like frequency, amplitude, speed, and force and break down exactly what's happening and begin to communicate about it precisely. And let's not forget that force is the resistance to needle movement, and it's very important to us, isn't it? We're feeling for that when we needle, and it modulates our motion, what happens with all the other motion dimensions. When we feel something happen, we often change what we're doing. And once again, this illustrates the same point that rotational needling measurements are a whole nother segment that we can analyze. So the Acusensor was a project to develop a tool to begin exploring needling in detail. And as you'll see here, it involves a force sensor, which hooks to the handle of the needle and makes it, I'm just looking, I don't see my cursor on the screen, but what I'm holding in the picture is the force sensor. And then there's a motion sensor, which uses optical laser technology to track the motion of the needle. So what can we quantify using the Acusensor? Well, we can quantify motion, and that's the top the top plot across there, and we can quantify force. This is an actual readout of a needling episode. And of course, motion and force can be broken into amplitude, frequency, and speed. Oh, thank you, Peter. So those can be broken into those things. And if you look at the, on this side here, the red corresponds on the top to the up and down motion, and on the bottom it corresponds to the axial force. And so the blue corresponds to the rotational motion on top and the rotational force, or what we call torque, on the bottom. So by capturing these two graphs, we get a full picture of the motion and force parameters that are occurring during needling. Now, how would this help? So what, we can do this. How would it help? Well, let's think about it again from the clinician perspective. How do we communicate about needling? Well, it's a lot easier when you're talking to your colleague if you can say, here's how I tonified spleen 6, and you show them a picture. Or you could translate it into a numerical description, but I think pictures speak to us even more clearly. And they can say, great, I know exactly what you did. From the researcher's perspective, how do we control needling manipulation variables? Well, wouldn't it be nice in our methods sections if we could say, active and sham needling were quantified using the Acusensor. And then the reviewer might say something like, all right, nice needling controls. Now let's work on, because they'll have to find something else to have you correct. So teachers, what about from a teacher's perspective? How will it help? Well, how do we teach needling skills? Now the teacher can say, here's a profile of the sedating technique that I'd like you to try. And they can do this real time, and the students can watch. They can take a picture of that, and then they can have the student in real time while they're watching and coaching try to mimic that episode. And what's really cool about it, it's almost like biofeedback. As they're needling, they see, I'm not doing it at quite the same speed, so they start to speed it up. Or the rotational amplitude's not quite as great, so they pick it up a little bit. So in a real-time way, you kind of get the feel for what, how to mimic your teacher, for example. How about this tricky question about how we deal with the minimal differences between real and sham acupuncture that we've been having in clinical trials? True needling isn't much better than fake needling with a toothpick. Well, an empowered researcher might be able to say, let's use this objective tool to really understand needling. Perhaps we can optimize the true needling and understand how to make the sham needling inert if we understand.